Hearty welcome to the video on application of dynamic software Geogebra. At this video, I wish to explain the application of Geogebra in various topics of mathematics from secondary classes to higher secondary classes. Let us see how the learning has evolved. In the beginning, I was a disciple in Gurukul, then I was a passive listener in class. When these activities in CCE were introduced, it was actively participated in teaching learning process. Now scenario has totally changed. The children are telling that I am digitally connected with you, sir. Now how can you follow the same teaching learning process? Now let us see how students learn. They learn by actively participating in observing whatever you are doing in the class, speaking with the children, writing, listening, thinking, drawing and doing. Learning is enhanced when a student sees potential implication, application, and benefit to others. For whenever we are introducing any topic, we have to tell that how it is potential implication is there in that, how applications is available for the topic, and how it is benefit. And we have to remember that the learning builds on current understanding only, including misconceptions. Now, this is a holistic view of the active learning where a child should have experience, information, and ideas and reflect whatever they are learning. And there is a triangle. This triangle shows you that what we remember, whatever we are learning or the child is learning, the reading 10% and hearing words 20% like that. But here it is showing that what are passive learning and what is active learning. And this triangle once again tell you the learning pyramid where average retention rate is how much through lecture to reading to audiovisual. And you are seeing that teaming active is discussion in group, practice by doing and immediate use. And after 2 weeks, whenever whatever you are teaching in the class, only 10% of what the child read they can remember, 20% of what they hear and 30% of what they see. Here you are seeing that 90% of what they say and do will be remembered by them. Therefore, there is a Chinese proverb, famous Chinese proverb, tell me and I will forget, show me and I may remember, involve me, then I will understand. Therefore, this triangle once again shows you that how the learning will enhance from remember, understand, apply, analyze, evaluate, and create. And it can be shown through this triangle once again. There, remembering goes up to creating. And all of you know that this is Bloom's taxonomy, which it tells you that the child should remember, should understand, should apply, to analyze, to evaluate, and they have to create something to learn better. And 21st century educator is having a lot of tasks at their hand, and they have to answer so many queries by the child. What we are strength, what is our weakness, how I am doing, what is really making me think, and so many questions we have to answer. And for that, to do this, the National Education Policy 2020 is giving some key principles. Use of technology in teaching and learning and removing language barriers. And in chapter 5 and 5.14, it talks about autonomy in choosing aspects of pedagogy. Teachers will be given more autonomy in choosing aspects of pedagogy so that they may teach in the manner they find more effective for the students in their classroom. Now, when you are choosing your own pedagogy in teaching learning process, you are having the liberty to choose any tool to make the learning highly effective. For that, we are going for FAST. What is FAST? Free open source software is computer software that can be classified as both free and open source. Anyone is freely licensed to use it, copy it, study it, change the software in any way. And it is contrast to proprietary software where the software is under restrictive copyright and the source code is usually hidden from the user. Now I have selected one free open source software that is highly effective dynamic software, Geogebra, so that a teacher can select his own pedagogy in the classroom and make your teaching highly effective. GeoGebra started from the idea of geoboard. It's a mathematical manipulate used to explore basic concepts in plane geometry, such as perimeter, area, and the characteristic of triangle and other polynomial. It consists of a physical board with a certain number of nails around which wrapped geo bands that are made of rubber. Rubber band can also be used. It was invented in 1950. I'm showing a geoboard to you. In that, now you are seeing that the geometrical figures can be visualized by simply removing the position of the nails in which the rubber band is being tied. You have to remove that and then put it so that a child can learn a triangle, the types of triangle, quadrilateral, and types of quadrilateral, and they can also learn about the perimeter and area of the geometrical figure. Using this idea, GeoGebra started Dynamic Mathematics for School. Joins it is a interactive geometry and algebra. That is why the word GeoGebra came. And most parts of GeoGebra are free, and it available in that website geogebra.org. Is written in Java. That's available for multiple platforms. There won't be any problem whatever the operating system you are having. Many parts of GeoGebra have been ported to HTML5 by using the GeoGebra web toolkit. Now let us see what is the journey of GeoGebra. GeoGebra started in the year 2001 at the university, continuing at Floral Atlantic University. And a secondary mathematics teacher is a lead developer for it. And GS expanded their offering to include in iPad and Android version also. Therefore, your smartphone can have GeoGebra in it. Now, let me explain you how you can download GeoGebra from the website. It can be downloaded free from www.geogebra.org. Now, the web page is going on changing. Now, I am showing you the latest web page, which looks like this. You can download it from www.geogebra.org. Now it can be used online also by clicking that start calculator. And there are some classroom resources already embedded in that. Therefore, you can click that max resources and you can use classroom resources online. And it contains activities for elementary, middle school and high school and colleges also. And now to download this GeoGebra in your computer, you click explore all to download the executive file of GeoGebra. You have to do only once and automatically it will become an offline tool for you. And explore all you click, then download the GeoGebra Classic 5. Now there are so many apps are there. Calculator suite, graphing calculator, 3D calculator, geometry, GeoGebra Classic 6, CAS calculator and GeoGebra Classic 5. But I recommend GeoGebra Classic 5 for you, those who are a beginner, and you can use, and because this GeoGebra Classic 5, it contains all that 3D calculator, it has calculator suite, it has graphing calculator, everything it has inside. Now you have to download this GeoGebra Windows Executive and simply run it in your computer by clicking next, 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 and you have to click agree, and automatically you have to select that install after selecting that standard setup, and GeoGebra will start installing. It will take maximum 2 minutes to get GeoGebra installed in your computer. Click finish to finish installation and GeoGebra will get installed in your computer, and this is the shortcut which will get automatically loaded in your desktop. Click GeoGebra shortcut icon on the desktop. GeoGebra will open and this is the GeoGebra sheet. This worksheet contains two parts. One part is algebra view, another is a graphic view. On the top, you are having the toolbar and menu bar, and there is a input help also and input bar also. Therefore, the person who removes a mountain begins by carrying away small stones. Okay, now I will try to explain or I will try to show you some of the worksheets prepared by me by which you can teach or a child can learn the topics, selected topics in GeoGebra. But the topics which I am going to show you, it is not at all extensive. The GeoGebra, you can use it for preparing a lot of worksheets for every concept of mathematics. Now let me show you some worksheets where you can make the child to learn, you can make the child to clear their misconceptions, and worksheets where you can give it as your homework to them or learning to them, and you can work it in the classroom also. Let me start with secondary classes. Representing fractions. Now normally we will be trying to represent the fractions in the class and try to explain them how the fractions are behaving, and normally the fractions are explained through the definition. Now let me show you a GeoGebra file where the fractions are represented diagrammatically, and you can explain them. What is a fraction, what is the meaning of a numerator, what do you mean by the denominator, and you can show them like this also. Now here I have shown you that 1 by 12, 2 by 12, 3 by 12 and so on. But in the class you can make any worksheet where it may be denominator maybe 13 or 14 or whatever may be. Now child can tell that the numerator defines the number of equal parts, the denominator defines the total number of equal parts. Therefore at one place you can stop and ask them what is the represented fraction also. Okay, well. Now you can modify this worksheet for any number in the denominator. Let me go to equivalent fractions. Normally questions will be asked in equivalent fraction. The child will be, one fraction will be given. The child has to give the equivalent fractions for the given fraction. Now I am going to show you a GeoGebra file where you can select your numerator. Now I have selected 5 by 7, and by removing it, and you can show them that what are the equivalent fraction for it, 5 for 5 by 7. Now I can change it also into 6 by 7, and automatically it changes. So any fraction you can take and ask them to find the equivalent fraction. 2 I have simply shown over here. Now the next thing is comparing fractions, which is smaller, which is greater. Now normally we explained in the class that the concept behind it, how a child has to compare two fractions. Now here I have made a worksheet where the new problem you can write. For example, I take 3 by 7, and let me take 4 by 9 for example. Now the child has to work out, and they have to find that either 3 by 4 is greater or 7 by 9 is greater. Now if you click this new problem, automatically everything goes, and you can now simply enter the first fraction and second fraction. The child knows what are the steps. You have to find the LCM, what are the fractions. The fractions are then which is greater, which is smaller. Now the another one is, normally the child will be having a lot of confusion in sum of fractions, because this is happening in even in higher secondary classes also. Whenever they have to add two fractions, they will do a lot of mistakes in that, a lot of misconceptions in that, and there are a lot of miscalculations are there. For example, I will take a 5 by 7, and I am just taking very simple one, and 3 by 8 for example, 3 by 8. And now you can in the class, now you see I have made a worksheets where you can stop in the class and you can show it to the children, and after the working out only you have to simply click this and steps of calculation will come out automatically. Now again you can go to the new problem, again you can have one more problem. This worksheet can be used in your teaching learning process. The child can also practice it by simply entering the fractions, and they can find the sum of the fractions. And the next one is problems on difference of fractions. Now you see in the previous worksheet, I have entered the numbers, then I have entered the numerator, denominator, the fractions were entered by me. Now I am going for a worksheet where this GeoGebra automatically creates problem. For example, new problem, new problem, new problem, new problem. So many problems will be created. And now if in the class you can show it new problem, come on, do it. Again, the next problem you can do it. Next problem you can do it. And after they have completed, you can show them the calculation. Here it is finding GCD, you're finding LCM, and it is showing you what is the difference of fractions. Well, now let us move on to some worksheets of addition of integers. Now normally addition of integers, you want to show it on a number line. Normally on the number line, when a child is visualizing the addition of integers or maybe the difference of integers also, I'm talking about both of them. Suppose I take 5, let me take 6. Now it will show them what is the answer on the number line. Now all of you may be interested to know that what will happen if I convert this into -6. Oh, it is going to -1. Now the child can go on change the first integer, second integer, and they now go to the new problem. Automatically, new problem comes. It automatically shows you the way how the addition is being done of integers. Well, let us move on to prime factorization. Highly interesting, because in the prime factorization in the class, normally we are going on tell them it all actually helps them for a child even in the higher classes also to do the factorization. For example, 37. Okay, let me change the number. Let me change the number into 156, for example. Okay, it actually shows, but you may be interested to know that how it is being done. You see, 156 divided by 2, once again divided by 2, once again divided by 3, and 13 has come. Therefore, 2, 2, 3, 13, it is the factors for it. Now, a child can enter any number over here. For example, 257. I'm just showing a number. Okay, it is a prime number, therefore automatically it is coming as 257 directly. Suppose if you have it as 258, for example, okay, it is coming 2346. Now a child can animation on, and automatically it gives him the way that how that 2 into 3 into 43 came. Now this is the way the child is doing, and this sheet shows that how the process has to be done. Well, no, let me move on to the square root of a natural number. In the class, normally we will give them a square root. We will ask the child to do it. And these worksheets give you the square root of a natural number directly. Not only that, you see new problem. Now you can in the class you ask them what is the square root of 32? 4 root 2. Now it gives you the third form also. Highly useful in the higher classes also whenever they are going to represent a number after a calculation is being done. Now you see, you will go on to new problem, new problem. Here I have taken a worksheet where it gives you only a number coming from 1 to 100, but you can modify this worksheet where you can have from 1 to 1000 also. Well, I move on to the factorization of polynomial. Highly interesting, because this factorization of polynomial not only helpful in the lower class, when they come to 12th standard also, they have to factorize a quadratic equation so that they can get the values. And you see here, new polynomial, whenever you are clicking, it gives you the new polynomial. Now the child, after it is over, they can click the next step, they can click the next step, and they can get the answer. Now the process is very simple, but the child will be always interested to know that, sir, how the middle term is split. When you click it, it will show you how the middle term is split. So that addition is 23, multiplication is 1. Now you can go to the new problem. Once again, new problem automatically given by this GeoGebra worksheet. Well, let us move on to the next one, exploring equation of a line. Normally, this is actually happening in class 9th and 10th, where a child should know the nature of a line, whether it is parallel to the x-axis, parallel to the y-axis, or it passes through the origin, or it is cutting the x-axis and y-axis like that. For example, you can take 3 and you can take 4 and you can take 0, for example. Automatically, it gives you a line which is passing through the origin. Suppose when I convert it into 1, and you know that it is happening like that. Suppose if it is very clearly written, if a is 0, line is parallel to the x-axis. Therefore, when I take this as 0, automatically you will get a line parallel to the x-axis. Suppose when I take this as 4 and this I will make it as 0, then you will get a line parallel to the y-axis. Automatically, now a child can explore the total equation of a line. What will happen when a is 0, b is 0, and c is 0? Well, I'm going for the next one. This is a system of equation solution. Highly interesting, because they should know it at, even when they are going to the class 12th also, uh, because they should know that the nature of the solution also whenever they are doing any problem. But this GeoGebra worksheets give you that solution of a system of equation, whether it is having a unique solution or it is having a mini solution, or whether it is having a, okay, well, now this is actually a first equation, second equation is there. Now you have to simply enter it. For example, 2, 4 and 6, this is actually having a solution. Suppose if I convert it into 8, for example, automatically you will get that the lines are coincide, the system is having many solutions. Suppose all of you know that a1 by a2 equal to b1 by b2 not equal to c1 by c2. For example, let me convert it into 3. Automatically we are getting that they are parallel, the system has no solution. Well, now every problem in the textbook or whatever you are giving, a child can enter only the first equation, second equation, they can check out what is the nature of the solution they want. Let us go to properties of triangles. Now all of you know that this is actually being there in the lower class, where a child can learn all the properties of a triangle in a single worksheet. They can move the vertices of the triangle and they can learn it. Now I am showing you the sum of the angle is 180, or they can move it and they can show it, it is 180. And exterior angle is equal to sum of the interior angle, so that also you can check. And any two side is greater than the third side, that also they can check. I think you can show it by moving this. For example, you can show one by one after the other also. Sum of the angle is 180. Now you can show them to the children by just simply moving it. And again the other property, sum of the any two side is greater than the third side, that also you can show by moving. Again the next property, exterior angle is equal to sum of the two interior angle, that also you can show by moving. Okay, one by one in the class, whenever you are doing it, you can show it step by step also. Now, some of the angles of a triangle animated. Normally, this will be done by cutting the paper and then asking them to paste it over a straight line. Now, in this GeoGebra worksheet, I have designed in a way that now a child can move it and then see it over there. For example, I am just moving it. You see that both the angles are moving and it is coinciding. The angle B and angle C are moving and it is coinciding, and then it is making 180 degrees. The same thing is being happening in that, but cutting the paper also. Well, now let us go to the centroid of a triangle. Now the centroid, circumcenter, incenter, orthocenter, everything can be shown using a GeoGebra. But I have selected only centroid of a triangle. Now in the GeoGebra sheet, what you can do is, instead of showing directly, you can tell them what is a centroid, and you can show them this is a triangle and midpoints are taken, and this is a centroid is the meeting point of the medians, and the coordinates of the centroid also you can show them by simply moving on this, and you can show them what is its properties. Similarly, orthocenter, incenter, everything you can show. But anyway, I will show you the circumcircle once again. Circumcircle, incircle, orthocenter, everything you can show using a GeoGebra. But this can be used in the classroom also after it is being taught. For example, you can tell them what do you mean by a circumcenter, and it is the meeting point of the perpendicular bisector. An highly interesting thing is, now for acute triangle, what will be the position of the circumcenter, and for obtuse triangle, what is the position of the circumcenter, and for obtuse triangle, what is the position of the circumcenter. You can show them by simply moving it. Okay, I am making it into a obtuse triangle, it is going outside. For right triangle, it is on the hypotenuse, and for acute triangle, it is inside. Now a child can understand about the circumcenter better. Well, now Euler line, this is actually a highly interesting idea. Now you can ask the child that what do you mean by Euler line. It tells you the all the about the triangle, and you can show them that it passes through centroid, circumcenter and orthocenter, and you can show them, and I am showing you all, and this is the Euler line, and you can move it and then show them that how it is moving. The centroid is moving out, circumcenter how it goes outside and come inside, orthocenter is going coming inside and going outside, but centroid is always inside. Well, now this is a extra idea a child can understand what do you mean by that Euler line. Well, now the similar triangle idea normally we will teach in the class, that what is the property of similar triangle, and corresponding parts of the similar triangle also we will always tell them that how to get it, then how to understand them. Two triangles are similar if the corresponding angles are equal and corresponding sides are proportional. I have shown that how they are proportional, and you can move this triangle and automatically you are seeing that the angles are equal, but the triangles are totally different, and corresponding sides how they are proportional also you can show them by moving this. Okay, this similar triangle idea you can show them. Now, can you show congruent triangle idea? Definitely. Congruent triangles, now you can use the all the criteria, that is SSS criteria, then SAS criteria. You can show them very clearly using GeoGebra that how that congruent triangles can be formed. Now I have taken SAS. I have taken two triangles, corresponding angles are equal and corresponding sides are equal. I am moving this and that also moves. And here the highly interesting thing about this GeoGebra is you can move it and put it over this and tell that what do you mean by congruence nature. Normally we'll tell in the class that they coincide, the two geometrical figures. If you put one over the other, they overlap. This can be shown virtually to the child in case of congruent triangles. Well, and Pythagoras theorem, normally we will try to explain to the children that how the Pythagoras theorem works out. That is by taking a right angle triangle and by constructing squares on all the three sides of the right angle triangle. And I have shown it over here, a right angle triangle I have taken, and I have formed three squares on every side of the rectangle triangle. Okay, now I can move it and I will show them that how this AC square plus BC square is equal to AB square. Now, while interesting thing is you can try by drawing semicircles on all the three sides of a triangle and then check out. I'm just leaving it to you to think about it. Well, then let us go to circle part, and you can show the child that how the parts of a circle are there, how a circle is defined, what do you mean by radius, what do you mean by diameter, what do you mean by circumference, what do you mean by uh, the radius, what do you mean by the parts of the circle. Now, I have just shown you here over here, and you can very clearly animate and then show them that what do you mean by the basic definition of a circle. Then you can tell them that what is circumference, and what do you mean by an arc, what do you mean by a sector, and everything about the circle can be viewed very clearly using GeoGebra. And the value of the pi, normally we will be asking the child that what do you mean by pi. Normally they know that 22 by 7 3.14, how it got explored. Then you can show it through the GeoGebra file, and they can visualize that how the value is very close to 3.14. Now I have taken that pi is circumference of the polygon by 2 into radius, and I am clicking this animation on, and you are seeing that it is going on changing, and you are getting the value of pi going very close to 3.14. But anyway, I have made it as the value of this one as maybe 2,900 or so. Okay, well, now you are seeing that how the value is going on changing, and you are going very close to 3.14. Well, then let us move on to the next one, tangent to a circle. Now all the properties of tangent to a circle, secant property, I mean connection between a tangent and secant, everything you can show it to a child using GeoGebra, and even you can show them the measurement also. And you are seeing over here that is the tangent is always touches the circle at a single point. A child will be asking, sir, how is it? Okay, you can show it through animation that you are seeing that it is touching at a single point also. It is not cutting the circle. Good. Now let us go to the tangent from an external point. As I told you earlier that you can show all the properties of a tangent. Tangent from an external point, then pt square is equal to pa into pp. All the properties or all the theorems which the child is learning and which is in the syllabus, you can show it to them. And this is a tangent from an external point are equal. I can show it, and I can, you see, it is always equal. And I am showing you no tangent can be drawn through a point lying inside the circle. Like that also, I think I have shown you one of the properties of tangents. Well, now, angle between the tangent from an external point. This is one of the basic property. Angle between the tangents from an external point. Then how it is being connected with the angle made at the center. Now this can be shown very clearly using GeoGebra. You see, now this is the angle made between the two tangents from an external point. This is an angle subtended joining the points at the contact of the center, and you can show it to them that how it is supplementary. When you add them, you will get 180 always. Well, now a child can move and they can visualize it also. As I was telling that angle subtended by an arc of a circle, this all of you know that it can be visualized by a child. And when there will be definitely one question normally will be there in the question paper with the angle subtended by an arc of the circle, and the child should know that what is the meaning of it, and they can show that it is twice, and they can move it and they can visualize it also. They can move it here also and they can visualize it. This also can be visualized, and you can animate also so that it goes throughout the circle. Well, now angle in the same segment, this again this property is used in so many places. The angles in the same segment property, the child can understand that by moving that circle that it is always the property holds good always. The angles in the same segment is always equal. You can show them, and I have shown you, and in one by step you can show. Just moving it here and then moving it over here and then moving it over here, and you can show. Good. Well, now let us move on to worksheets on quadrilateral. It's a very vast actually. Normally parallelogram from quadrilateral. Then how to get the parallelogram from the quadrilateral? We know that there is a theorem on that. When you join the midpoints of the sides of a quadrilateral, you will get a parallelogram, and I have shown it. Now from the quadrilateral, the properties also I have shown over here, and when you move it automatically that it also moves, but the inside it is always a parallelogram. Well, now a child can move and then they can visualize it. And quadrilateral by joining midpoints of a parallelogram. Now a child will be having an idea, sir, I have taken a quadrilateral, I have joined the midpoint, I got a parallelogram. Then what will happen when you take a parallelogram and join the midpoints of the parallelogram? And this idea of exploring can be done using GeoGebra. Therefore, quadrilateral by joining the midpoints of a parallelogram, and I am just showing it to you. I will take this polygon. Okay, this can be visualized. Okay, let us go to the next one. Okay, now quadrilateral by joining midpoints of a rhombus, what will happen? Let us show it. Okay, when you take a rhombus, when you join the quadrilateral by joining the midpoints of a rhombus, what will happen? Now that when you take a quadrilateral and joining the midpoints, you are getting a parallelogram. When you take a parallelogram by joining the midpoints, what will you get? By taking a rhombus, when you take the midpoints, when you join them, what will you get? What will you get? When we'll get a rectangle. Now this can be proved also by a child. This can be proved also by a child by checking it also. Well, let us move on to properties of a trapezium. I think this is another idea that the child can visualize a trapezium and they can list out all the properties of a trapezium, all the properties of a parallelogram, all the properties of a rectangle can be visualized through a GeoGebra simply by drawing a trapezium over here. The length of the midpoint is equal to half of the sum of the parallel bases. Sum of the two pairs of the adjacent side is 180. This how everything can be visualized. Then let us go to regular polygon. Then the child will be knowing that what is a regular polygon. Then from a starting from a equilateral triangle, you can go up to side 10. For example, I am showing you that these properties of a regular polygon, and I am showing it. I'm just clicking that animate, and automatically it will going on changing, and you are seeing that the number of sides are going on changing, whether it is becoming a starting from a equilateral triangle, it goes to a square, it goes to pentagon, it goes to hexagon, it goes to heptagon, octagon, nonagon, and decagon. And I have shown up to side 10 number of sides. Now they can visualize it. It's equal measure of the interior angle, and some of the interior angle also the child can visualize it from this. Well, let us move on to the next one, cyclic quadrilateral. Very simple. I think one of the properties of a cyclic quadrilateral the child can visualize by simply moving it, and they can visualize it, and that some of the angles it the text also comes in GeoGebra. That is one of the advantage. You see, it is not only showing you the figure, it shows you the summation, everything it shows by the side of it, and I can remove it, and either pair of opposite angle of a cyclic quadrilateral is always 180. Well, now child can visualize it. Good. Let us go to the problems of solid figures. Let us go to regular pyramids that you can show them the regular pyramids and its properties through GeoGebra to a child. Child can simply visualize. Now all of you know that we can take a regular pyramid to a class and we can ask them to feel it. That is a one way of doing it. Now here I have shown you that the regular pyramid. Now suppose I am going on changing it. You see all the pyramids are coming. Height I am changing and I am showing it also. You see I am going on changing the side also. First I am having 3 triangle, then 5 pentagon, like that you can show everything to them. Okay, regular pyramid as a regular polygon as its base. Now child can visualize for all the regular pyramids at the same time. Now regular prism. Now the child can visualize what is the difference between a pyramid and prism also. They can visualize a prism. That also I have taken a regular prism over here, and you can show it to the child that for a regular prism what will happen if about the base, then it is a three-dimensional solid figure. Two ends are identical. The base once again you see triangle, then square, then pentagon, and so on. Then you can visualize it, and the child can move it and they can visualize it also. And here I am showing you the surface area also being calculated by GeoGebra automatically. Then now the child can visualize cubes, cuboids, square, sphere, cone, cylinder using GeoGebra. But anyway, they can feel it by when you are just giving you a solid figure in their hand. But here the idea is you can visualize the cube over here and you can change it also. Length of the diagonal, everything will come automatically. You see what is this? All of you know that we can show them this also to a child. You can open it and then you can show them all the sides of it. Good. Similarly, you can go for visualizing cones. Cones also can be shown. Cylinders can be shown. Spheres can be shown. An hemisphere can be shown. But here what you can do is whenever you are making any worksheet on solid figures, in not only you can show them the solid figure, by the side of it you can show its calculations also. That is one advantage of it. You see visualizing the cone, and you can show them the cone, and you can change the height also, and you can show the radius also, and you can rotate it, and you can show them also then how it's what is the base, then what is its surface, lateral surface area, everything you can automatically show them. Good. Then you can make use of this GeoGebra, and you can show them that volume of a cylinder. What is the meaning of volume of a cylinder? I have taken only cylinder. Similarly, you can show volume of a cube, volume of a cuboid, volume of a cone, and volume of a sphere also. But for example, I have taken only volume of a cylinder. Now you can, when you show this height, for example, I am just showing the radius, and you can draw the height, that then volume of the given cylinder and volume of the liquid, it is also showing there. And you can at one spot you can stop, and you can ask the child that when radius is 4, when the height is 5, find the volume of the liquid. Like that you can have. Really interesting. Well, let us move on to worksheets on statistics. Now this pie chart is a very interesting one, where you can show the child that how the angles are being calculated, then how to draw it, how to show the given data in a pie chart. Now I have shown you. Then here one example I have taken, number of students and center angle also it is being shown. Now when I change it automatically, when I change it into 15, the figure automatically changes. When I change into 20, again it changes. So pie chart is a pictorial representation. Now a child can visualize it by simply changing the uh, data over here, and they can calculate the center angle also. Well, now let us move on to grouping a given raw data. It's highly interesting. Now a raw data is given, how to group them. The GeoGebra worksheets using statistics will automatically gives you the table. But anyway, I am not showing you very clearly. Now this, I have taken very at random one raw data I have taken. Then over here, now whenever you are having the histogram and you can have a bar chart for the given this one you can have. Okay, well, now it is having a idea of histogram and it is having idea of frequency table and everything you can have. Now this can be shown to a child. You can ask them to show the histogram. You can ask it to show the frequency table. You see it, so going the frequency table. In the frequency table also, at random it is taking from 10 to 27, 27 to 40. Now you can change the set classes manually and class rule manually, and you can show what will be its length of it also you can show manually also. The classes manually you can show, and you can set the what is the frequency polygon you can find, and frequency this one. For example, width is 5 over here. I can make the width as 10. For example, normally 0 to 10, 10 to 20. You see automatically it comes. And it shows the histogram, it shows you the frequency table, and it shows the frequency polygon, everything it shows automatically. Therefore, you can give the raw data. I think this sheet can be used by simply changing this raw data. In that spreadsheet, you have to simply copy the raw data automatically. You will get the cumulative table, histogram, frequency table, and frequency polygon automatically. Let us go to mean of the ungrouped data. Now, all of you will be interested to know the mean. Here, actually, highly interesting GeoGebra worksheet where you can simply give the data to a child. For example, number of values, I want to be 15. It gives automatically the arithmetic mean. Now you can simply show the calculation, it will tell you the arithmetic mean. And for example, I have 20 values, automatically it gives. Now remember, this is a worksheet where automatically it gives you the data. You are not typing anything. This can be shown to a child, they can have a practice over finding the mean. Now, mean of the group data also you can show it to a child with all calculations over there. Here I have made a GeoGebra worksheet where I have taken a example where I have taken the marks and number of the children. Now it can be changed by you also. These marks you can change, number of students you can change. Whenever I'm changing over here, for example, this 25, I will take it into 35, everything changes automatically. It gives you the arithmetic mean, it gives you the arithmetic mean formula also, and gives you the table also. Now child has to simply explain. Here I have taken only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can expand this table also, and calculation is being done automatically by the GeoGebra worksheet. Then you can move on to the median of ungrouped data is highly interesting. Now in the class, the child has to arrange them in the either the ascending order or descending order. Now this GeoGebra file will automatically arrange it. You see, find the median of the given data. For example, I will take the values as 20. Automatically it comes. The median automatically it comes. Given value in the arranging ascending order, descending order, and there are two middle terms. Therefore, it tells you. For example, let me take it as 21. It tells you there is only one middle term. Therefore, this is the median. But this worksheet can make the children to practice over a median of the given data and the total value. Total value can be directly entered by you. That's all. This GeoGebra worksheet tells you directly. For example, I have only 11 values. That's all. 11 numbers are coming. Ascending order coming, descending order coming, and it tells you that what is the median. Well, let us move on to the worksheet on application of trigonometry, which will be highly useful in class 10th standard, where a child will be trying to know that how to apply the trigonometry in height and distance. But now one worksheet can be found by explaining them the values of sine theta, cos theta, tan theta also. Okay, now I have made it as an example. A kite is flying at a height of 100 meters. Now here I can make this 100-meter also, I can convert it into 50 meters, and this angle also I can change it into 60 degrees. It gives you the answer automatically. Now, so many questions can be framed by simply changing the height of the kite and angle of the inclination. Now, child can understand that how from the triangle ABC the length of the string is found. Well, let us move on to problems on arithmetic progression. It is highly useful in class 10, normally in class 10, in class 11 also. Here I have made a worksheet where the problems will be created automatically by this GeoGebra worksheet. Now new problem I am taking. Now you have to take only the T23 and S23 it is asking. Now you have to check the steps and you have to check the steps. Now the child can understand that what is the answer. Now you can go to the new problem. This can be used in the class after the topic is over, or this can be used for giving them homework or assignment. Find T11. You see new problem, find T34, T41, T37. Arithmetic progression is being generated by this GeoGebra worksheet. Well, now let me go to problems on geometric progression the same way. Now I have made a GeoGebra worksheet where geometric progression problems will be created. The child can use it and child can learn better. Now the first term is 7 and the common ratio is 0.5, number of term is 5. Now I can go for uh, number of first term is 8, automatically it changes, and new GP, and you can directly enter it, and every step is being shown in this GeoGebra worksheet. Let us move on to visualizing conic section. This is in class 11, where you can show them that how a parabola is formed, how a circle is formed, how a hyperbola is formed, how a ellipse is formed in order. Now there are two ways of explaining them. You see, I am showing them the circle now. The circle is being shown with animation, and you can show it like this also, how the circle is being formed. Now I can show parabola to them, how the parabola is being formed. You see, parabola is formed. How a ellipse is formed, I can show them how a ellipse is formed. It's okay. Well, now in the conic section part, you can make them to explore parabolas by simply entering the values of that A. For example, they have a lot of confusion to analyze that which will be the right hand side parabola, which will be the left hand side parabola. Suppose if I take 8, for example, they can see it is a right hand side parabola. Suppose what will happen if it is minus 8? They can have it immediately. Similarly, new problem, then they can have x square is equal to 4y. They can visualize. What will happen if x square is equal to minus 4y? They can visualize. For all the four types of parabola, they can visualize, and you can use it in the classroom also to show them that how to understand the different types of parabolas. Well, now I think you can explore ellipse also in the same way, because there are two types of ellipses where based on that value of a square and b square, and you can, in the worksheet which I have prepared, you have to simply explain this is type 1, and you can show them by simply changing it, and automatically it changes. B also you can show them by changing. This is type 1 parabola like the ellipse. You can show them type 2. You can show them a worksheet where all the ellipses can be shown. Let us move on to concepts of limits. This is highly interesting. The limit idea can be shown by using this GeoGebra file. All of you know that I have taken very, very simple example. Normally we will start in the class that x square minus 4 divided by x minus 2. Normally we will start with that only. I have taken it, and you can show them that how the value approaches. It is not in 2, it is not defined, but how it approaches when this limit is going very close to 2, and you can show them that it is going to 4. Now this can be visualized. Okay. Then standard trigonometric limit, normally the child will be having a problem because it is coming in class 12 also, where I have taken only one standard trigonometric that limit x goes to 0, sin x by x. Now you can show them that how it will come. For example, sin 2x when it comes, sin 3x comes, the child will be having a lot of confusion. Now making use of this, and you can show them that what is the meaning of sin nx by nx, and limit x goes to 0, sin power nx by x power n. It is highly useful for them because child is always having a lot of misconception in these standard limits whenever it comes to application part. Okay, now let us go to graph of the functions. Now this actually normally in the class we will ask them, we will draw it on the board, or we will show them the uh, any graph on the screen or something. But here you see I have made one sheet where constant function you can animate, and it will show them that how a constant function is going on and what is the meaning of the constant function. And you can input this b also. Well, now let me move on to identity function. Now a child can understand that what do you mean by identity function. Well, and you can show them that what do you mean by a signum function. Then all the functions which are there, and greatest integer function, let me show you that greatest integer function. Now how it goes, that you see step function, we are going on telling that how the step is being made. Now the child can learn that what do you mean by the step function. Similarly, they can learn the modulus function, because I have taken only those which are available for the child that animate. You see, this is a modulus function. Now the V-shaped function, normally we will tell that this is a V-shaped function, how it is being traced. The child will understand that when they see it, then they will never forget the graph of the function, because it is highly useful in class 12 whenever application of trigonometry integration comes. Okay, now let us move on to operation of matrices. Please remember that all the matrix operations can be done using GeoGebra. For example, I have taken only a normal operation. You can find inverse and you can ask them to solve equations and all. You see here I have made a very simple worksheet making use of normal operations on a 2 cross 2 matrix. For example, new problem, and you can ask them what is a plus b, what is a minus b, what is scalar multiple, what is the transpose, what is scalar multiple, and what is the transpose. Very simple. Now remember, GeoGebra worksheet can be used to find inverse of a matrix, and problems can be given, and expansion of determinant of a 2 cross 2 or 3 cross 3, and solving equations also, system of equation also, you can make use of GeoGebra. Okay, then normally the child will be having a lot of confusion with one function and onto functions. Now you can make them to visualize one function and onto function using GeoGebra also. Well, now let us go to increasing and decreasing function idea. Now these increasing and decreasing functions, whatever the problems which are there in our textbook, we can make a GeoGebra worksheet separately for all the problem. For example, I have taken a problem sin x plus cos x, which is a famous problem in our textbook, where I have drawn the diagram. First, let me go for a definition. X increases, value of f(x) increases. When x increases, value of f(x) decreases. Now you can move it and then show it to a child. A and f of a is being shown over there. Okay, then we will go for the test which we are normally making use of. So maybe f dash of x is increasing, decreasing, and so on. And you can show them that how the slope of the tangent is positive, how the slope of the tangent is negative. You see, whenever it is going on increasing, slope of the tangent is positive. When it is decreasing, slope of the tangent is negative. And here the highly interesting thing is you can show the nature of the second derivative also. All of you know that the nature of the second derivative also being used for maxima minima. Well, let me show you the another problem on increasing decreasing function, because I want to show you that any problem which is there in all the textbook, any function can be entered in GeoGebra file and you can show them the graph of it. Normally we will not show the graph to the child, we'll normally use the idea. Now this I have taken one problem from our textbook where x square into e power minus x, again the same thing, slope of the tangent is negative, and we can show them that how the slope of the tangent is negative, how the slope of the tangent is positive also. Is it okay? All the problems in our textbook, we can make a individual GeoGebra worksheet for all the problems of increasing, decreasing, maxima, minima. Let us go to local maxima and local minima. This I have taken a problem from our textbook only, NCERT textbook, where it is a famous problem where a child will be doing that problem by making use of the procedures. But let us visualize it using GeoGebra. This is a 2 cos x plus x, and critical points are pi by 6 and 5 pi by 6. Now you can move it and then show it to the child that which is the local maxima and which is the local minima. We are just simply moving it. And I am showing you the first derivative curve also over there. Okay, you can explore it. Okay. Now absolute maxima minima also you can show it to a child by drawing the graph of all the problems in our NCERT textbook or whatever the problem which is coming in any textbook or even in CBSE question papers, and you can show them that how the maxima, minima absolute maximum minimum is coming. Critical point I'm showing. And from pi by 6 to 5 pi by 6, how the absolute maxima and minima is coming. Then you can show them that from which region, from 0 to 2 pi or 0 to pi. Anything you can show them by simply moving this. And it is actually advisable after the problem is totally done by making use of the procedures, then you can show them this graph sheet to them so that they can understand better. Okay, then in linear programming, and all of you know that normally we will be shading that, showing that this is the region for that inequality and all. In linear programming can be visualized very nicely by this. For example, this is the first line x plus y less than or equal to 8. The second line x plus y greater than or equal to 4. X plus y less than or x less than or equal to 5. X less than or equal to, sorry, y less than or equal to 5. Everything can be shown, and you can show them the feasible region also, and child can visualize totally. Anyway, they are going to do it on a graph sheet. After doing it on a graph sheet, they can compare it with this GeoGebra graph sheet. They can learn better. Well, now let us move on to straight lines in space. I think all of you may be interested to know that, sir, can I show that a three-dimension idea? You can straight line in space, you can show plane, you can show, then you can show how the lines are parallel in a three-dimensional space, and you can show them that how the skew lines are being formed. Here I have taken two lines, x minus y by 2 is equal to y minus 2 by 3, and they are meeting at my minus 1 and 1. This, I think all of you know that the child will do it by the point of intersection and all, and they are visualizing it, and I'm just showing it to you on a three-dimensional. Now, skew lines also you can show it on a GeoGebra worksheet, and you can show them that how the skew lines are behaving in a three-dimensional space. Good. Let us move on to visualizing planes, and all of you know that the planes can be shown with the different colors to a child in a three-dimensional geometry, and you can show them that how two planes are meeting. Anyway, this planes idea is deleted in NCRT, but anyway, I think the child can visualize that what do you mean by a plane. You see, this is the plane, two planes I am just showing you, then I'm showing you the how they are meeting also. Well, okay, now after I have given you only maybe a tip of the iceberg in GeoGebra worksheets. There are plenty of worksheets can be made, and you can make the child to learn any class, maybe from class 6 to class 12, even for colleges also this GeoGebra can be used. The main aim of this GeoGebra is very simple. The child can understand better, misconceptions will not be there, they can have a lot of practice over there. Suppose you may be interested to know that, sir, how I can make these GeoGebra worksheets. You can view the video tutorial on how to prepare these worksheets at the YouTube channel. Now at the description box of this video in the YouTube, I have given this link also. Now suppose you want to learn GeoGebra by joining Google Classroom also. This link also it is available in the description box. There I have made lesson wise where you can start from introduction, then how to use the tools, then how to make triangles, how to make rectangles, then how to make worksheets on properties of triangle, how to make worksheets on circles. Everything I have explained over there. Okay, well friends, I wish to thank you for watching this video by through a GeoGebra worksheet also, because I don't want to thank you normally by simply thank you. Or I want to thank you making use of a GeoGebra worksheet. Now my request is very simple. Please make use of this GeoGebra in the classroom and make the children understand and enjoy mathematics. Now, I wish to tell you that I have been designated as the brand ambassador for GeoGebra by the GeoGebra community. Now, the basic idea behind this is the ambassadors should promote GeoGebra, which is a free open software. Therefore, I am making this video to make you aware of GeoGebra. It is available. Therefore, make use of it and then make mathematics a very, very interesting subject. Thank you, friends.